This particular data set has been downloaded from Kaggle. Downloaded this particular data, drug 200 for about 200 patients, I think so. So what is it data about? Given a patient's characteristics, which drug would be the most appropriate? So you have 5 drugs, drug A, B, C, D, E, and a list of patients, and for each of the patients some characteristic information. What is this characteristic? Age, sex, whether the person has, what is the cholesterol level and what is the BP level. These are the characteristics. And for this, and sodium to potassium levels. So for these characteristics, which drug has been used, and can we give, when we get a new patient, given this information, can we say which drug works well? That is the prediction. So when we give a new patient information, the output is which one of these 5 drugs would be better. So that's what you need to start with the question and an endpoint. Depending on that, you need to clean up and use the data. So the first step is we need to install the libraries. So how do we install? I have already shown you pip install pip pandas. Because we have multiple libraries, all have to be installed, but once installed you don't have to install multiple times. Once installed, it's done. Then we need to import the libraries: pandas, numpy, matplotlib, seaborn, and sklearn. In this sklearn, training and splitting, random forest classifier is one model, decision tree classifier is one model, and this is the confusion matrix. These are the matrices. So these are the basic default parameters which we need to load. Library which we need to load. Then we need to load a data set. So we are loading a drug 200.csv. Let's see how does it look. Drug classification, and let's open this. So this is the table: age, gender, BP levels, cholesterol levels, sodium and potassium, which drug is used. So there are 5 drugs, I think so, A, B, C, Y, and X. This is the information. Based upon these information, we are trying to predict which drug would be best suited. Now let's load in the data. So we read, this is a CSV file, so we read it as a CSV file, and we are seeing the first few lines. That's the same how we have opened in the notepad. In the same way we see here the first few lines, and after that we need to get the shape. For 200 individuals we have the data, and we have 6 columns: 1, 2, 3, 4, 5, 6. And what is the information you have? Age, you have data for all 200 people, and it is a data type of integer, means it has a numerical value. Gender, sex, again the information is for 200 people. The information is object. Object means it has a character: male, female, M and F. BP, again an object, because it's not the number, it has been given as a category: low, normal, and high. Cholesterol level, again an object. Here they didn't give the cholesterol level, they have given low, normal, and low, normal, or high, normal, I think so. And then sodium potassium level, it's a continuous number, it's a float, means decimal number is float. And the drug, the data type is object. Why? Because it have the drug name here. So that's how you get the information. And now let's describe the table. Describe means this information you get it only for the numerical values. Means in this table you have only 2 numerical columns: age and sodium to potassium. This table works only for that. And then it gives you the count, mean, standard deviation, minimum value, what is the maximum value. You don't have to do any analysis, you have to just give describe, and it gives you the distribution of the data. What is the median? 50% is your median. What is the minimum value? What is the maximum value? What is the mean? How much it is deviating from the standard deviation. This tells you how good or how bad the data is as well, if you get into the details of it. Check if there are any null values. Obviously we know there are no null values because all rows are filled with something or the other. So there are no null values. Now let's get some insights or information of how these plots, or what information is there. The first part is count plot from SNS. So we have used this particular library, seaborn SNS, In this library, we are using count plot function and we are generating a plot. So use the drug information on your x-axis and count how many people have been prescribed with drug Y, how many people have been prescribed with drug C, drug X, drug A, drug B. This plot can be generated by just one line, passing the table, the entire information in which your table you have saved, that's the data frame, and on which column you would like to plot. So from this information it's clear, right? You have drug Y is the maximum users, followed by drug X. That's how we start understanding the data. Then, based on BP, get the count plot. Majority of them have high BP, low BP and normal. They are normal people who have a normal BP as well, means no low or high. Now, generate a count plot for cholesterol. You have high cholesterol and normal cholesterol. That's it. You have only two categories here. And how is the age distributed? Age is a continuous variable, right? It would be distributed. So their count plot doesn't work. So you need to give a hist plot. So it says that you have an age group from 20 to approximately 70 or 80. That's how your age is distributed. Now, how is your sodium to potassium level distributed? Because it's also a continuous variable, you can't give a plot, count plot. So we give a hist plot. So you see, many of them have a Na to K ratio, something around this, and followed by lower levels. I think it's not ratio, it's the levels. Now, the next part is the data cleaning. Data cleaning means, here in the previous table you have seen that you have the names mentioned, right? Like low, normal, high, female, male, low, normal. We can't have this data like text. You can't have an object or a text there. We need to convert it into a 0 or 1. So if it's a female, it's 0, male is 1. If it's low, it's 0, normal is 1, high is 2. So that's called encoding these variables. So for that, we don't have to do it manually. You have a called encoder, label encoder, and we pass the column. Okay, the sex mark, go to the sex column and just encode it. So by default, it makes it 0 to 1. What is 0? What is 1? It changes based upon the alphabetical order. So 0 is female. F comes first before M, right? That's the reason 0 is female, M is male. In the same way, BP 0, 1, 2, 0 should be high, low, normal. H, I, J, K, L, M, N. So 0, 1, 2. They are arranged in an alphabetical order and the encoding would be given. Okay. So we give encoding only to the categorical variables where you can divide them into this group or that group. You don't give it for a continuous variables. Once you give it, this is how your data frame looks like. Now this is ready to go for your model building. So how do you build a model? First you need to split the data into two subparts. So X, which has a set of independent variables where everything should be there except the drug column, right? And Y, only the dependent variable, only the drug should be there. So the big data set is divided into two smaller tables where X has only the independent variable information and Y has the dependent variable information. Next is we split the data X and Y into two again, 80%. Your test set has 20% of the data and the remaining is your training set. So you have training X, X test, Y train, Y test. So you have divided it. And now previously we used random forest classifier, right? Here we are using decision tree classifier. We take this and say that make a model for a decision tree classifier and then fit the model with the X train and the Y train data. Learn based upon these parameters and try to make a prediction whether that person whether the drug is suitable for that person or not. Once you make your model learn, here you are declaring which model to be used, which parameters have to be passed, should be given here. As I have shown you, these are all the parameters which can be passed. And then we say fit the model. X train and Y train, we say fit it. means the learning has been started, and depending upon the type of the data, size of the data, and the processor which you are using, it takes its own sweet time to complete. Then once the model is learned, the next thing is we predict it. We predict it on the test set and we check the accuracy. The accuracy is 1. It's simulated data. We are using some data. This kind of a data getting 1 is usual. You don't have to worry because we are just learning it. It's okay to be 1. But if you say your model accuracy is 100%, 1 is 100%, please don't use that model for testing. That's called a overfitted model. This is an example of overfitted model. It learned so well that it can predict everything correct, which can't be true always, which can be true always. Okay, then let's see the confusion matrix. So this is the actual, this is the predicted. Based upon the information, it says that 15 people have been using drug 0. Drug 0 is what? Drug Y. And our model also has predicted that these 15 people are using drug Y. There are no any mispredictions, 100% accurate. 6 people are predicting drug 1, 6 people are using drug 1 actually, and the model has also predicted that 6 people are using drug 1. 3 people are using drug 2, the same thing has been predicted. It's 100% accurate. That's the reason you have got the accuracy of 1, and there are no false positives or false negatives, right? That's how your classification report is. And out of all these features, we have 4 or 5 features, right? Age, sex, BP, cholesterol, and sodium to potassium level. Which parameter, 1, 2, 3, 4, 5, out of these 5 columns, out of these 5 variables, which variables are most important? 6 is least, 0 importance. The most important variable is sodium to potassium, then followed by BP, then age and cholesterol levels. So that's how you can know which is the most important feature to classify, to say that which drug is best suitable for whom. Okay, so this is another model. I mean, I've just used a random forest classifier at all, and with that also we got a 1% or 100% accuracy. Now we made a model, we are sure that accuracy is also high, and we know which are the important parameters. Now let's enter a new patient data in the same way as we have in our table. How we have in our table? Age, gender, BP, cholesterol, sodium to potassium. Okay, in the same way we need to enter. So let's get a new patient data. Age, gender, cholesterol, BP, and sodium to potassium levels. And we say that when this particular information has been provided, make a prediction which drug suits well to him. It says that drug Y. It says drug 0 means 0th index, I mean 0th label. That 0th label is drug Y, right? So that's how when you have a data, you make it learn. So let's continue, zip through it once again so that some of the concepts would be again clear. We import, we load, we see the first few lines, that's okay. And we got to know that there are 200 samples and 6 columns. And each column, what is the kind of information, you get it here. And then you visualize to get which is the most widely used drug and what are the different levels of information available in BP, cholesterol. And then we have converted it, that's called encoding of the categorical variables. This is the most important step where we convert high, low, normal to 0, 1, 2 scale. And then we make this bigger table into smaller tables. So one has all the independent variables and this has only the drug information Y. And then we split this data into training set and the test set. We make the model learn using the training set. The learning is happening depending on the parameters of X. What is the Y? It starts learning here. And then when you provide the test set, it predicts it, right? And the accuracy is 1. That's okay. Let it be. Not a problem. But generally this can't be deployed because it's overlearned the data. And that's the confusion matrix. And this is interesting. of the parameters, gender didn't have any role to play, and sodium to potassium level has the highest significance. Like approximately 50% is contributed by it, and the rest contributes the other 50. And then when we get the new data, the model has learned and it has tested. And now when I give a new sample data, that's the age, that's the gender, that's the BP level, and whatever it is, sodium to potassium level, and it says that use the drug 0. What is drug 0? It's drug Y. Okay, just provide the values which is the best drug can be used. That is the output of the model.